Okay, so we're going to continue looking at manual matrix multiplication. So if you remember, we were talking about it the other day when we have a matrix by another matrix. And remember, the first thing you have to do is check the order. So if I was looking at this one, this is a 2 by 2 and this is a 2 by 2. So it is possible. And then what we looked at, so why we said it was possible, because the columns in the first one equals the rows in the second. So we ended up with that. And then we also looked at, we're going to have an answer of a 2 by 2. So this one is going to end up being an answer of a 2 by 2. So you can see you'll have 2 rows and 2 columns. So here is where those 4 elements are, so the 4 answers. So we also looked at how we do sort of run and dive. So this first element is found by multiplying these 2 numbers with these 2 numbers in this column. So the first row in the first column. So remember what I said. So look at what you're in. So because I'm in row 1, column 1, I'm using row 1, column 1. Say here, this is row 2, column 2. So I'd be using row 2, column 2. So they've given you an example here. So when we got 2 multiplying, and there's another example of what's happening, but we're going to do some ourselves. So let's give this a go. So it says the following matrices. So probably good to put the orders up here. So A is 3 rows by 2 columns. B is 2 rows by 1 column. C is 1 row by 3 columns. And D is 3 rows by 1 column. So determine the following matrix multiplication by hand. So we want to manually do them. So if we look at doing A first. So what we've got is we're going to multiply A by B. So I might write that one out. So I've got A, which is 5, 4, 1, 2, 6, 3. And I'm multiplying it with B, which is an 8 by 9. So as I said, you first probably want to check that it can be done. So this is a 3 by 2 and this is a 2 by 1. So yeah, it's defined. And what's my answer going to be? It's going to be a 3 by 1. So what I expect to see is a column matrix. So I'll have 3 rows in it, so which means I'll have 3 elements and the 1 column like that. So I'm going to do it in different colors to help you. So if I look at this one is row 1, column 1. So I'm going to use row 1 with column 1. So it's going to be 5 times 8 plus 2 times 9. Yep. And then the next one, if I look at this one, this is row 2, column 1. So I'm going to use row 2, column 1. So it's 4 times 8 plus 6 times 9. And then if I do the last one, this one is row 3, column 1. So it'd be row 3 with column 1. So 1 times 8 plus 3 times 9. So if I kept just tidying that up, so I'm just going to do those multiplications. So 5 times 8 is 40, and it'll be plus 2 times 9, which is 18. Then 4 times 8 is 32, plus 6 times 9, which is 54. And then 1. So I'm just quickly done those multiplications, and then I could keep tidying it up, because remember, I want to have a 3 by 1. And when I finally add them all up, I do. So I end up with a 3 by 1. Okay, so we've manually done it. So it's a good point to go check it. So let's go check it on our calculator. So remember, matrices are just done on a normal calc page. and we can click the matrix. Now I want a certain shape one, so I picked that 3x3 button. Now I want a 3x2 to be my first one, so enter, and then I pop in my elements, which was this 1 and 3, and then I want to multiply it with a 2x1. There's a quick key for that one, and I pop that in 8 and 9, and then I'm going to check was I correct? Yes, so that's good. So I'm off and running. Okay, so let's go do B now. So B, they want me to multiply C and D. So C, if I write C out, you guys can see it up there, is 247, and D is a 3x1, 6 and 5. So if you look at this one's a 1x3, and this is a 3x1. So when we multiply it together, my answer should be a 1x1. Yeah? So we're saying it's defined, yes, and my answer will be those numbers there. So a 1x1. So always, I reckon it's good to sort of draw out what you're expecting. So I'm expecting just a set of matrix with just one element in there. Okay, so we do that. So that one element is coming from row 1, column 1. So it's going to be 2 times 8 plus 4 times 6 plus 7 times 5. So you can see, unless it's defined, it won't work. You won't be able to sort it out. Okay, so if we tidy that up, 2 times 8 is 16, 4 times 6 is 24, and 7 times 5 is 35. And if we add all them up, and there's our 1x1 matrix. Okay, the last little bit of this chapter we're going to look at is called matrix powers. So what a matrix power is obviously you have, say I have matrix A and I raise it to a power. So say A squared is a power. It's the power of 2. What that actually means when you see something squared, it means that you're multiplying that number or that thing with itself. So when you've got a matrices squared, it means you're going to multiply that matrix by a matrix. Now, matrix powers only occur if the matrix is square. So only in square matrices. So what's a square matrix?
It's one that both rows and the
yeah.
And
So a square matrix is when we have rows and columns the same. So 2x2 is an example, 3x3, and so on. Okay? So if you have A squared, what you're doing is doing that. If you have, say, a matrix raised to the power of 3, what it means is you're going to multiply it by itself 3 times. So that's all you need to know. You just need to understand that that's what powers are. Now you can see I've written there as well, and I've brought it. You only do these on the calculator. You never have to manually. If they got you to do a square, it'd just be 1x1, but they won't do it. We just do them on the calculator. So you can see here, when they asked me to calculate A squared times B, all I do is I know there's powers involved. You just go straight to the calculator. So here you can see I've typed in matrix A and I've raised it to the power of 2. Now I'm just going to show you in case you're not aware of that. So here I've got that 2x2 matrix and I've popped in the numbers. So this one's 5 and this is 2. So when you want to raise a matrix to a power, you need to move your cursor outside it. Then there's this little arrow button next to the x squared or alongside next to 4. You do that and then you can pick what power you want. So because I wanted 2, I do that. Now you just need to move your cursor over so it's not up in the power, it's down on the normal. And then I'm going to say times, and then it wanted me to times B, which I can't remember what it was, whatever B was. B here. So here's B. So you can see I've done that, and here we go. We get the answer. So the thing you have to remember, matrix powers, only if it's a square matrix. If they ask you to raise another one that's not square to the power, you would say that's false. It's not an answer. So it would be something you'd be crossing out on a multi-choice, something you can't do. But it's a fact you should always remember. Now, the other last thing we're just going to talk about is they'll talk about an identity matrix. So an identity matrix is a matrix that is also square. So important, it's a square matrix. And it has ones along its leading diagonal. Now, if you remember, I said the leading diagonal starts in the top left-hand corner and goes down to the right. So that's an identity matrix, and then it has zeros everywhere else. And it sort of acts as like a number one. And what I mean by that is if you times something by 1, so say, for example, just in normal maths, if you times, say, 3 by 1, you get 3. So if you times anything by 1, you get the same thing, don't you? Yeah? So that's the same with matrices. So if you have a look here, I've taken, this is matrix A, and we often use a capital I letter to represent the identity matrix. And you can see I've multiplied A by the identity. Now, can you see I end up with A again? So see how an identity matrix, it's like a number one. It hasn't changed the value of that original matrix. Now, you could also times it at the front, and that's the same as in our maths. So when I said I could have 1 by 3, I'm still going to get 3, aren't I? Yeah? So here, when I did the identity by matrix A, I still ended up with matrix A. Okay, just the facts you need to know and remember about that. We may need to use an identity matrix when trying to solve something later on, but that's all you need to know.